The functions g and h are given by g of x equals 3 ln x minus 1 half ln x. H of x equals sine squared x minus 1 over cosine x. Rewrite g of x as a single natural logarithm without negative exponents in any part of the expression. Your result should be of the form ln parentheses expression. Okay, so let's start with this. A, Roman numeral I. We're going to rewrite g of x equals, I'm just going to rewrite the original just so that we have it here. Now keep in mind, anytime you have ln's and they're subtracted separately, to put it together, you would divide. So I have x, and now remember, anytime something was in front, you can put it to the top, which is the exponent. And once again, whatever's in the front, you put it to the top. So x to the half. Now that is good, but we still have to simplify. Whenever you divide terms with the same base, you keep the base and you subtract the exponents. So 3 minus a half. Remember, there's an invisible 1 on the bottom. Whenever you're adding or subtracting fractions, you need the same denominator. So if I multiply 2 on the bottom, I multiply 2 to the top. So 3 times 2 is 6. So 6 minus 1 is 5, and common denominator 2. So we have ln x to the 5 over 2. So g of x equals ln x to the 5 over 2. Okay, that's our answer. And now let's look at Roman numeral 2. Rewrite h of x as an expression in which cosine x appears exactly once and no other trigonometric functions are involved. So basically, we want it in terms of cosine x. All right, so I'll just do this here. So it's already written here. So I'll put this A, Roman numeral 2. So you have to remember your trigonometric identities. The most common one is sine squared theta plus cosine squared theta equals 1. So as you can see here, we have sine squared x. So in order to rewrite this in terms of cosine, this would be sine squared x is the same as, well, put together they're 1, so 1 minus cosine squared x. So here we'll rewrite this, h of x equals, so instead of writing sine squared x, I'm going to put 1 minus cosine squared x, and then I have a minus 1 at the end. Now notice that 1 minus 1, they cancel, that's 0. So now I have negative cosine squared x over cosine x. So I'm going to cancel a cosine x on top, so that gets rid of the exponent, and I'm going to cancel a cosine x on the bottom. So we're left with negative cosine x. So therefore, a Roman numeral 2, the answer is h of x equals negative cosine x. Now we're up to part B. So part B, functions j and k are given by j of x equals 2 sine x cosine x minus cosine x, k of x equals 8e to the 3x minus e. Okay, so B, Roman numeral I, states solve j of x equals 0 for values of x in the interval 0 and pi over 2. Okay, what is going on here? Okay, so I want to substitute j of x for 0. So let's do that. So b of I, 0 equals 2 sine x cosine x minus cosine x. Now we're going to treat this like algebraic equation. And so what do we have in common? We have cosine x in common. So I'm going to factor out a cosine x. So we have cosine x times, so 2 sine x. So cosine x times 2 sine x is 2 sine x cosine x. Cosine x times -1 is negative cosine x. And so these are our two factors. So cosine x equals 0 and 2 sine x minus 1 equals 0. So what cosine of what gives us 0? Cosine of pi over 2 gives us 0. And now opposite of -1 is +1, so we add 1 to both sides. So 2 sine x equals 1, divide both sides by 2. So sine of what angle gives us half? Well, in degree format, although AP Precalculus, we don't use degree, but degree format, sine 30 is half. And we know that 30 degrees in radian format is pi over 6. And so what do we have? We have that in the interval of 0 and pi over 2, just in case you don't understand. If I were to change this with a common denominator of 6, you multiply 3 in the bottom, multiply 3 in the top. So 3 pi over 6 is the same thing as pi over 2, and you can see pi over 6 is still within this interval. So for BI, our answer is x equals pi over 2 and x equals pi over 6. Okay, so now let's look at B Roman numeral 2, this one. So we're doing the pretty much the same idea, but this time we're going to set k of x to be 3e. So 3e equals 8e to the 3x minus e for values of x in the domain of k. Okay, so we're going to solve algebraically. Opposite of minus e is plus e, so we have 4e. Then what we're going to do is divide by 8 on both sides. So I have half e equals e to the 3x. Now I want to get rid of this e, so I'm going to do the ln of both sides. So l and e cancel, and so we're left with 3x equals ln e over 2. Now opposite of multiplication is division, so divide both sides by 3. So x equals ln, remember, division is subtraction. And remember, ln e is 1. So, in this section, you can't use a calculator, so you have to memorize that. So, ln e is 1, and so x equals 1 minus ln 2 over 3. And that is for B Roman numeral 2. And now we're up to the last question. So the last question says the function m is given by m of x is cosine 2x plus 4. Find all input values in the domain of m that yield an output value of 9 over 2. So output value of 9 over 2 is another way of saying y. So we're going to put 9 over 2 at the end. So let's do this here. So 9 over 2 equals cosine 2x plus 4. And just like we did before, we're going to subtract 4 on both sides. It's just basic algebra. I'm going to do this math on the side. So 9 over 2 minus 4. Remember, there's an invisible 1 on the bottom. So we need a common denominator 2. What you multiply on the bottom, you multiply to the top. So 9 minus 8 is 1/2. So here we got 1/2. Now, cosine of what will give us a half? Well, that would be cosine of 60 degrees. And although we don't use degrees in AP Precalculus, it just helps us to remember what radian would go with that. So 60 degrees is pi over 3. So we know cosine pi over 3 is half. But right now, we have that 2x, and so 2x is pi over 3. You divide both sides by 2, which really means multiply by a half, and so we got pi over 6. So x is pi over 6. But keep in mind when it says all input values, then that means you're going to have any integer n times pi. So that's all possibilities for that part. Now, you also have to understand the unit circle, right? All students take calculus. So pi over 6 is here. That's where cosine is positive. But cosine is also positive here, not here or here. So we know that the whole unit circle is 2 pi. And remember, this right here was pi over 6. So if I just subtract pi over 6, I'm sorry, let me write this down. So we know that before that 2x was pi over 3. Now another option I could have written also because of the other quadrant right here would be 2x is 2 pi, which is the whole circle, minus pi over 3, because that part right here would be pi over 3. I'm sorry, this was pi over 3, sorry. Okay, so we already solved this part. This was given over here. And so now we're doing here. So common denominator of 3. So what you multiply in the bottom, you multiply to the top. So 6 pi. So 6 pi over 3 minus pi over 3 is 5 pi over 3. You want to solve for x, so divide both sides by 2, which really means multiply by a half. So we get 5 pi over 6. So not only is this the answer for the left part, now this is also the answer for the right part. So it's 5 pi over 6 plus n pi. So that's our final answers, this and this.